As you may know, Fluidity is the company behind the AirSwap project, which of course is one of the leading decentralized exchanges. And when AirSwap launched their product, it really set the groundwork for how we could represent financial transactions and execute transactions in an optimal way. And what that allowed Fluidity to do is take a step back and understand how we could build on that technology in order to affect a lot of transactions in the financial space. So for the past several months, we've taken a look at the capital market space, and we've looked at the types of transactions that happen in that industry and tried to figure out how we could develop on the technology that has already been built so that we could have an impact in changing the way financial transactions are done within capital markets. And really, when we've gone through that kind of investigation, we've started to develop views on how a financial transaction can be represented through smart contract technology. So what this discussion really is about how we can apply a framework to capital markets transactions that are complex in a way that leverages the benefits of smart contract and blockchain technology. But before going into really understanding how we can leverage the technology, I think it's good to level set on exactly what a financial product is in a very rudimentary way. So what a financial product is really a representation of a contractual right or ownership to some sort of asset. Classically, there are two ways that financial products are really described, in stocks and bonds. And a stock generally is described as a fractional ownership of an entity. And that ownership really gives you rights to the income of that entity. So if you owned a stock in Amazon, you would be granted ownership potentially to a dividend if Amazon was going to distribute that dividend periodically. A loan, on the other hand, or a bond on the other hand, is really a loan. And what that represents is ownership to a stream of cash flow that is really required for the repayment of that loan. So generally, that repayment is broken up into two different components, principal and interest payment. But when you hold a bond, you are owed principal and interest payments because you granted a loan to an entity based on your choice. So this is a very simple way of understanding what a financial product is. As you move into capital markets, financial products become a lot more complex. And our task is really to understand how we can model that complexity using smart contract technology. So to understand that, really need to step back and think what drives complexity within capital markets transactions. So within capital markets transactions, I'm going to use nomenclature here, and abstraction nomenclature around vertical structure and horizontal structure. For a capital markets transaction, what I mean by vertical structure is the characteristic of a capital markets transaction in that it is often broken up into different classes. And you'll hear the word tranche thrown out, but a large financial product is typically broken up into different components, and those components represent different tiers of risk. Sometimes they're known through the terminology of senior through junior, but if you own a senior portion of a capital markets product, you are owning a less risky portion of that product. And what that really means is in the form of payments and losses. When payments are made against a capital markets product and you own a senior portion of that capital markets product, you're entitled to be paid first. And in the case of a loss, you are basically suffered loss in the last case because you are holding the least risk. Conversely, if you're owning a junior portion of that product, you will face losses first in the case of a loss scenario, but you will also be paid last. And the trade-off to holding a junior portion of this type of product is that you typically are paid higher rate of return for taking that risk. Horizontal structure is the characteristic, as I describe it here, of a capital markets transaction as having value that is based on a base of underlying assets. So you can think of a pool of different assets which generate cash flow, which then flow to the product level that is offered by a capital markets institution. One very prominent example of this is a commercial mortgage-backed security where underlying assets are, in effect, loans. And when you're investing as an institution or institutional participant in a capital markets transaction that includes a commercial mortgage-backed security, you're really entitled to the payments that are based on the underlying loan set flowing through that product at a higher level. So the two aspects which drive complexity are vertical structure, which is tranching of the specific product into different portions of risk, and horizontal structure, which is the amalgamation of different assets which produce cash flow that then flow through the larger financial product. So given that there is complexity within capital markets products, the question becomes, how can we use blockchain and smart contract technology to model that complexity so that we can impact transactions using blockchain technology? And so the first place I'll start is around vertical structure. Remember, vertical structure is the characteristic of a capital markets product in that it is broken up into different tranches which reflect different risk. So the need is for a smart contract to be able to reflect the different tiers of risk that are associated with this larger financial product. The way that that can be done is through a design of a smart contract that has a parameter around class. And that class really identifies the portion of risk that a token holder that is buying or holding a token within that smart contract would have. So in this example, this particular product you can think of as a loan that's broken up into 4 different tranches. There's an A note, a B note, a senior mezzanine component, and a junior mezzanine component. And it goes from most senior to most junior, the least risky at the top to the most risky at the bottom. The way that we would model this in a smart contract is we would build a smart contract that would have a parameter around class, and then we would be able to create 4 ERC20 tokens, each of those representing a specific tranche within that financial product. At Fluidity, we've taken a stance, or we've taken the position that it's very advantageous for you to represent the entire capital stack within the smart contract programming that is used to develop to support a deal, even if a specific deal only requires the issuance of one part of the stack. And the reason for that, and there are many reasons, but the one that I'll focus on is valuation. The process of valuing a given token really requires mechanics around understanding the cash flows associated with holding that token and the cash flows you are due because you own a specific token. And the only way that you can really perform that analysis is if you understand how each part of the capital stack is performing. For example, if you were a token holder of the B note, the amount of cash flow that you would potentially be owed is really determined by the performance of the A note, because if the A note isn't performing well, you're less likely to be paid what you are owed because you're more junior in the capital stack. And as I explain more, the more junior portions are paid last. So for us to really have a process that is impactful in the capital market space, we need to have mechanisms where we can value transactions accurately, and that really requires us representing the entirety of the capital stack within a smart contract. So a lot of the smart contract development that we've done, even if there's an issuance of a specific portion, we'll program the entire stack within our smart contracts. An example of this is some work that we did on a property that was not too far from here under the deal called Factor 805. So this particular deal required a loan of $32 million to a developer to develop a condominium here. And we developed the smart contracts to represent this all on the blockchain. Specifically, when we were doing this for the particular issuer in this example, we were really only focused on the junior portion of the class, the $8.7 million portion of the deal. However, we developed a contract that was able to produce ERC20 tokens across the entirety of the capital stack, even though there was no tokens distributed for the senior class. And that was a design decision that we took under the premise that you can really only come to an accurate valuation of a specific token, in this case, the junior portion, if you have the full capital stack modeled and within the smart contract. So that's really how we think about representation of vertical structure within smart contracts. The next aspect of complexity is around horizontal structure. And as I mentioned, this is really around the representation of underlying assets that are often associated with capital markets transactions. So for any given capital markets deal, it can rely on thousands of underlying assets that are producing cash flows that need to be in some way monitored in order for us to provide exhaustive coverage at the deal level. So in this particular example, we have a sequence of different types of collateral which underlie a capital markets product at the top end. The way that we are able to accomplish accommodation of the horizontal complexity is really by creating a smart contract that defines non-fungible tokens, and each non-fungible token is made to represent each piece of collateral that needs to be defined under this larger deal. So if there were 1,000 pieces of collateral, we would define 1,000 non-fungible tokens, and each of those would allow us to get a picture of the entire product. For each non-fungible token, we would take specific attributes of the underlying asset. So if it was a property, we might take in specific attributes of that underlying property, which would allow us to, at an aggregate level, understand characteristics of the entire product. But the base way that we accommodate for this design is by producing a contract that allows us to model these as non-fungible tokens. So an example of accommodation of horizontal structure through this design is, for example, the modeling of mortgages, which is a very core financial product in our society. So a lot of capital markets transactions and products rely on underlying collateral in the form of a mortgage. So we need to think about how we can accommodate the modeling of a mortgage within a non-fungible token so that at the deal level, we're able to take in information on the underlying data. And so for a mortgage, we may think about what sort of data we would hold within our smart contracts that would be useful for the process of having a analysis done at a deal level, a commercial mortgage-backed security deal level, for example. And an example of the type of parameters we would capture are listed here. So we would actually take in data around the loan, but we would also take in data around the property. So we would understand where it's located, how big it is. If it's being appraised, we would take in that information. And then finally, we would look at the servicing data, are payments being made on these properties, and that would help us understand how the top-level security is performing based on the underlying loan performance. So given that we're able to model complexity both through understanding complexity around the different classes of risk and then accommodating for a whole pool of assets, we're able to really model very complex capital markets transactions. So here's an example of what a securitized product would look like, and an example of that is a commercial mortgage-backed security. The process of securitization involves taking a pool of assets and grouping them together, and then building a financial product on top of it, which is then tranched out for different risk levels. Because we can, through our ERC20 tokens, represent different risk tokens, and at the collateral level, represent different types of collateral and different pieces of collateral within our non-fungible token, we can create a representation of an entire deal which really takes in the full complexity of a securitization. Now, this is quite significant. If you think about problems that occurred during the financial crisis a decade ago, a lot of that a lot of that was a result of us not having full transparency on the quality of the underlying assets. And when we build in design around smart contracts that require us to take in information of the underlying collateral, we have more transparency on how underlying assets are performing, so we can understand if a commercial mortgage-backed security should be valued the way it is. So the power of this design is that it accommodates for a lot of transparency and information that then can flow up to a capital markets investor. I've described how we can accommodate for complexity in really defining capital markets products through smart contracts. One of the benefits of defining complexity is that it sort of changes the process that a capital markets institution has to go through when they put a deal into market. So I've put up here an example of what the current process is and why it's somewhat problematic. When a deal goes to market, there's a process of doing due diligence that's often done on spreadsheets very manually. And then from that diligence, a term sheet is provided between the borrower and lender to review. And once that's finalized, we produce loan documents which represent the final agreement between a borrower and lender. Once the deal is signed, through the life of the deal, a lot of the servicing is still handled on spreadsheet form. This is very problematic, not only because it's quite manual. A lot of the constructs that are used to model deals are somewhat archaic, and we're using spreadsheets and documents. But it's also problematic in that it's very error prone. And oftentimes in capital markets institutions, you'll see that the cash flows that are monitored during servicing, which should have been predicted by the initial diligence documents, are not the same. When you model these through smart contracts and you're putting information on the blockchain, and then we're capturing information relative to all the assets also on chain, we're able to automate a lot of the information gathering and produce these documents and produce a lot of the calculations and payment reports in a way that's much more automated and less likely to have errors within the process. So a benefit of really applying smart contract technology to define complexity is that we remove a somewhat problematic process with one that is a lot more efficient and a lot more less likely to have errors. So I think that brings us to where do we move beyond where we are currently in order to really impact the capital market space. We understand that we have the ability to model complexity in smart contracts. We can model the different risk tranches, we can model collateral, but really what is going to be required for us to scale this in a massive way in capital markets. And I think a lot of the process that's involved in producing smart contracts that are comprehensive and covering a capital markets deal is not so much in the actual modeling of the contracts, but it's in understanding the information that is required to go into those contracts. And right now, there's not really a good process by which different deal terms can be taken from the legacy documents and then used to program a smart contract. So what we think potentially is a good next step for the industry is to develop sort of a uniform framework that capital markets institutions across the industry can align on how they would transfer information relative to their deals to some type of format that can be used to produce smart contracts. Right now, the process involves sifting through a lot of loan documents, sifting through a lot of terms that are sometimes bespoke and varied across institutions. We need a way where we can really centralize that process in a way that the information we're taking in is somewhat standardized so that it's more efficient in translating the information into a smart contract design. So I think before we get to the point where we're really able to impact the industry through modeling of complex transactions, we need to have a uniform, adaptable framework where many institutions can transfer information about the nature of their deals in a way that can be consumed by technology companies to produce these contracts. And with that, I'll leave you with a link here to our token white waterfall paper, which really describes this in a lot more detail on how we can model complexity and develop smart contracts. Yep.
So, you were talking about that we need like a uniform standard that
Yeah.
the community kind of accepts. Do you have a proposal for such a standard?
We've worked with many different institutions. We haven't come up with a single standard now, and I think it's probably going to be driven by a larger understanding of the universe of transactions that are out there before we propose something that probably is going to be adoptable by a lot of institutions. So I think we're a little bit away from where we need to be there.
What challenges do you see, or how do you see addressing the challenges of operating on a public network that has irrevocable transactions?
Yeah, I think this presentation here is kind of agnostic to the type of blockchain that would be used to model complex transactions. This process that I described of understanding complexity in different risk tranches and complexity in the base collateral is really something that needs to be solved across different types of blockchains. So yeah, I'm not implying that we need to necessarily use a public blockchain. No.
How much faster are you guys compared to standard like Excel sheets and documents?
I'm not necessarily sure in terms of like processing time of transactions, but I think a lot of the efficiency is gained in kind of the servicing aspect of taking in information around payments and producing reports that need to be done on a periodic basis. That we haven't really quantified, but there seems to be a lot of manual processes that occur under that part of the process that we could maybe automate.
It's like, I guess, the big vision of this, if you underwrote it, there'd be a lot less costs, and then, I guess, end consumers would have lower rates on their mortgages.
Yeah, so for the capital markets transactions, I'm not necessarily sure how it would manifest itself in terms of rates. But yeah, definitely we think that there's going to be cost savings across the entire life cycle. And I don't know if that results in rates at the commercial mortgage-backed security level changing, but I think ultimately, yeah, we probably see changes in rates at kind of the end consumer level.
This is generally a question, though. If you see this as kind of a timing mechanism, the technology to be able to help automate everything is advancing pretty quickly. But the same systems that have been in place for a long time are still there.
Yep.
So you see something of an overlap that the technology is going to be so mature by the time that these lagging techniques are there that you're basically going to be fighting the same battles that have been going on for a long time.
Yeah, I think.
It's going to become the same problem it's trying to replace.
Yeah, I think maybe the evolution will require development of new applications that's built upon a new data layer, which is a blockchain data layer. So you won't necessarily be using those legacy systems that are currently being used now.
This would be a good question to finally get rid of this.
Yeah.
This would be a good argument. I hate those legacy systems personally. I don't want to hate them.
I'm asking this sort of approach, but how, like from an ignorant standpoint, just from like watching The Big Short, how much of this inefficiency is caused by not being able to model it versus just incorrectly modeling it? Because it sounded like it's like they built these layered tranches and they just, for some reason, assumed it was all like AAA when they stacked it with stuff that wasn't, and they just kind of, no one wanted to, like, even do the due diligence to dig that deep into the portfolio.
Yeah, I think it's a problem with how easily accessible the data is and how standardized that data is for someone to do diligence on. And the power of doing this through this technology is that it forces you to standardize the way that data is added onto the chain, and it also allows for accessibility of that data. Because depending on the blockchain solution you use, some of it may be public. I think a lot of the problems for the financial crisis were driven by the opacity around that data. People didn't really understand the quality of the underlying assets. Here, where everything is modeled and required to be modeled in order for you to have the transaction in the first place, it removes that kind of barrier.
Just to make the distinction, when you say modeling, are you modeling like essentially the credit risk given the value of the tranches, which is kind of similar to what you were saying, like you're defining what risk level a tranche A, tranche B, C, D would be, or is it the fact that you're actually linking the tranches together such that if the first tranche will fail, the second one will only get paid out, or will not get paid out, and that makes it so when you issue like these large debt portfolios of different tranches, they're actually rather than like they're actually like 3 years long contract.
Yeah, when I use that term modeling, it's not necessarily us determining what the levels are for the tranching. I think that analysis is still done by a capital markets professional, but it's really understanding how we can represent the decisions made there within the contracts. Yeah. Correct. Yeah. Any other questions? All right. Thank you.